This video is going to be Kink method part 1. So what we're going to start with is a box that we're going to draw our cross section in. We also have the stratigraphy labeled on the left, and we've got our sleds, is what I call them while I'm teaching. We've got our sleds up here at the top, where we've got this little hinge point on the sled, and the big side is pointing and indicating the dip direction. So for example, this sled is representing a strike and dip, where the dip is moving down in this direction. So just for example, if I had north-south across my cross section, then I would say that this is roughly horizontal. This one is indicating a dip to the north, a pretty steep dip to the north, horizontal again, horizontal, a moderate dip to the south, and horizontal or shallow dip to the south. So that's what those mean. Also, I've got lines over here on this side of my cross section, and I'm just going to assume that in this example that these beds continue over. So you might have knowledge of this maybe because you've got a well over here and you've drilled down, and you have maybe a well over here and you've drilled down. So you have some information about what's going on at depth, and then you'd collect this information by moving around on the surface and doing some field work. So what we're going to do in Kink method is we're going to try and represent bends or stratigraphy that happen subsurface based on the dip method, or based on the strike and dips we have at the surface and the stratigraphy. So what we're going to do is we're going to find the hinge points of these sleds. So find, and I'm just going to take notes down here, find the points on adjacent sleds. So for example, for these two sleds, we're going to find these are adjacent, so we locate those points. And here we're going to assume that there's no topography. We're just going to make this as simple as possible. So our topography is flat, really easy to walk. Then we're going to locate the midpoint between sleds. So we'll have the midpoint between the sleds. Then we're going to project the sled dip on either side of the midpoint. So here's what this is going to look like, just to give you an idea. We're going to have maybe two sleds that look something like this. We're going to locate the midpoint between the sleds. So here's this one, here's that one. So from this point to this point, the midpoint might be about right here. So we have this middle line between the sleds. And then we're going to project the sled dip on either side of the midpoint. So what that means is up here on the, let's say that this is the topography. We would come up along that topographic line. We would sketch out a dip on this side parallel to the dip of this sled. And on this side, we'd sketch out a dip parallel to the dip associated with this sled. And so that would give us this bend. The fourth step is going to be to bisect the angle you create. So that means cut it in half. So if I go up here, and I'm going to use the angle from this example, say it looks like this. I'm going to measure that with my protractor and divide it by 2, measure out what half of that is, and plot my bisector. So on either side, this angle is the same. And what you have done then is you've created zones of dip. So on this side, any of the lines that are on this side of this zone of dip are all going to be horizontal. And once I cross over this into this other zone, then they're going to be parallel to this layer. Okay, so let's try this and see what some of this looks like. Okay, so I'm going to go up here to this these first two points, these first two sleds. I'm going to make my life easier, I'm going to kind of think about where they would meet on the topography, where those points would meet the topography, and then I'm going to measure them and measure them and find the midpoint, or bisect that distance. So for me, this is about 1, 2, 3, 4, 5, 6 sixteenths. So 3 sixteenths would be half of that. So 1, 2, 3. Put a tick mark. That is the midpoint. So I'm going to go ahead and draw that in as a really faint vertical line. Okay. So now what I need to do is project the sled dip on either side of that midpoint, and I'm going to do it from the topography. So over here, the dip is horizontal. So I'm going to come up here and starting at this point, I'm going to draw a horizontal line. All right. And then on this side, I'm going to draw a dip parallel to this dip. And if you want to be really, really precise about this, you can measure the angle if you want. Okay, so now I'm kind of at this point where I have these sides projected. All right, now I've made this angle. I need to bisect that angle. So I'm going to come up here and measure it. And when I measure that angle, I get, for the big angle over here, I get 124. So 124 divided by 2 is 62. So now I'm going to bring my compass over, or sorry, my protractor over to 62 degrees. Okay. All right, that's my angle bisector, is this right here. Okay, so what that has done is it's created some zones of dip. It's created two little zones of dip. In the zone on the left, we are going to have everything, all the units dip horizontally, and in this zone on the right, we'll have units that dip at this angle. So I'm going to continue this on down. Into the subsurface. So right now we've got zone 1, zone 2. But you can see over here that this dip changes also, that it goes from steeply dipping back to horizontal. So we're going to have to repeat this process over here. Project that point down, find the midpoint. Seven eighths is 14 sixteenths, so 7 sixteenths. 7. Okay, so this is parallel to this. This is parallel to this. And notice that the point that I'm starting from, that I'm drawing from those lines from, is on the topography. Now I need to bisect this angle. So we'll measure that angle. And get about 120. So I'm going to come over to 60. Okay. And so now I've got a new zone of dip. Now this is my zone 1, this is my zone 2, and this is my zone 3. Zone 3 continues, but you can see over here that we're going to have a change in dip again. So we're going to repeat this process. Find the midway point. Over here, dip is horizontal. On this side, dip is going to be parallel to this dip. And then we're going to bisect that angle. There are other ways online that I've seen people do this. So I get about 160. So if you've got a different way to do it that gets you the same result, then I am not going to fight you on using that method. Okay. Zone 1, Zone 2, Zone 3, Zone 4, and now we're going to level back out to horizontal. Midpoint. Horizontal on this side. Going up on that side. Bisecting. I get about 156. 156 divided by 2 is 75 plus 3 is 78. Okay. All right, so now I have all of my zones of dip established. So what I'm going to do now is I'm going to recognize that G, this layer G, is expressed at the surface, and it's expressed again over here at the surface. But it's going to follow these zones of dip. I'm going to do some erasing just to clear this out a little bit. So in this zone, G has to be dipping horizontally. So I'm going to go ahead and draw in G dipping horizontally. And actually, all of the units are going to be dipping horizontally in this zone. I stopped at D because I need to continue this down. Also, get yourself a good eraser instructor. Like, don't fight it. You're gonna do lots of erasing. Just breathe. Know that it's gonna happen. You're gonna do some erasing. It's not the end of the world. Okay. All right, so now I've got my horizontal layers. As those layers enter this zone, they're going to take on this dip. So going through this area, they're now going to be parallel to this dip. Okay, notice that I need to lengthen my zone. Go ahead and lengthen all my zones. You're going to notice that they intersect each other. We'll deal with that in a minute with our erasers. Okay. Continue these up. Okay. Now I'm going to go back into a zone where everything's horizontal again. So I'm going to draw G in. Looks like G is at the surface. Very, very shallow at the surface. Or sorry, that's F. That's F coming to the surface. Right? These need to come back down. They need to match this dip over here. And then they're going to need to meet up with the dips, or with the spaces that they meet the surface over here. But notice that over here, these are supposed to be horizontal. So what is that we must have missed something when we were in the field. So there must have been some extra piece of information about dip that would have allowed us to go ahead and carry these units over. So what I'm going to do is honor the fact that at this location we saw a horizontal dip. So I'm going to go ahead and take all of these out horizontally to around where in the field we measured the horizontal dip. This won't happen in all kink band problems. This is just because I took a really traditional problem and I tried to adapt it, and so it's just a little bit of like a computer error type thing. All right, so now what I'm going to do is I'm going to adjust this by taking this dip and carrying it down to this top of F. So I'm just going to assume that I guess there's something that I missed in the field. I come down. That. This looks like there might have been a little bit of thickening. I probably just didn't draw that in perfect to begin with. I also think I need to bring this over a little bit as I come down at depth. So I am working to maintain bed thickness as I sketch this. So if you're pretty new to structure still, it's going to take you some time to be able to kind of eyeball your bed thickness. I wouldn't stress about that. It'll happen with time. Okay. So now we get to a point where we have these lines down here and they're kind of bunched up. So what you're going to do is erase those lines. These lines aren't really there. If we were in the field, we might see them as like a shear zone or something like that, but they'd just be places where all of a sudden our strike and dips, or definitely our dips would change. One thing you might find too as you start to move through kink band problems is that there's a lot of possibilities for what could be correct in some of these. You could interpret a fault to be in one, which is what we'll look at next. You could make a lot of interesting interpretations that could all be viable, but you want to go for the one that's kind of the most parsimonious, so the one that is the simplest and most likely explanation. So that is the kink method. Again, what we did was we found the points on adjacent sleds. We located the midpoint between the sleds. We projected the dip on either side of the midpoint, I should say, from the topography. So midpoint on the topography, that's where we did our projecting out of the dip. We bisected the angle we create, and then we let that bisector or the bisection create zones of dip. Thanks.